I got two of these correct. 0.3.
I agree.
0.3.
Yeah, you don't have to bring that to me, because I'll tell you what she thought. That one there, I think she might have thought it was, I don't know. Put it over there on my computer, okay? I agree with you. Okay, I'm putting together a couple of Venn. A Venn diagram is two circles that are connected, okay? They have a center part that they have in common. Do you remember seeing Venn diagrams?
Yeah.
Okay, now then, if I'm going to do a Venn diagram of the multiples of 4 and 18, I'm going to start by just listing those multiples of 4, right? Okay, so Chance, what are the multiples of 4?
Like all of them?
Start naming some multiples for me.
1 and 4.
No, those are factors. Multiples, meaning to multiply. So your first multiple would be 4, wouldn't it? 4, 8, 12. What comes next? 16, 20. Keep going.
24.
24, 28, 32. Okay, I'm going to stop right there for a minute. Let's think of 18. We know we have 18. What's 18 times 2? 32? Okay. Let's go one more on it.
No, wait.
Or can I stop?
36.
Ah, it's 36. Okay, so 36. Keep going.
54.
54. Can I stop right there if I want to?
Yeah.
Have I already seen one that's in both?
Yes.
And if I look at this, I've got a 36 here, and I have a 36 there. Do you agree? So 36 gets put in the middle. Okay? That's the first multiple that they share in common. So that means that that is our least common multiple. I'm going to erase this one. I don't want it out there in the Venn, do I? Okay? So the LCM of these two numbers equals 36, right? Okay. Can you do 9 and 16? We did these two together. Can you do 9 and 16 now? And while you're doing that, I'm going to set up this one. Tyler, can you list the multiples of 9 for me? Pardon? Okay, those are factors. You're listing factors. I'm wanting multiples. It's 9 multiplied how and all the different things I could get. So, let's start with 9 though, right? And then 18. What comes next? 27. What's next? 36. Keep going. 45.
54. I mean
54.
54.
63.
72.
Okay, surely we've gone far enough. What about 16? What's the multiples of 16? Well, we all know 16. Do we agree?
Yeah.
What's 16 times 2? What's 16 times 2, Braden?
32.
32. 16 times 3?
48.
48. 16 times 4?
64.
Did you say 64? 16 times 5?
60.
Have we found one yet? Do we have a common multiple yet?
No.
16 times 6? 96?
96.
16 times 7?
112.
Are we right with 112?
Yes.
Have I got one yet? And I'm going to have to keep going, aren't I?
Yeah.
Until I find it. Is this a method that you like?
Yeah. No.
No. No, because we haven't found it yet and we're still having to multiply. And we would have to keep going until we found the first multiple that they share. Not a method that I want to use. Would you like to learn a different way?
Yes.
Me too. So I'm going to move forward. Okay, let's use the list. The list method. All you do is you start listing it. 4, 8, 12, 16, 20, 24, 28. Now I'm going to stop there. And why would I stop there? Have I gone plenty far enough, Chloe? Yeah, because if I look at 6 now, I've got 6, 12, 18. Do I already have what I'm looking for? Right there. LCM of 4 and 6 is 12. Okay? Pretty simple. Could this take a long time though?
Yes.
It could. Let's find out if you can do it. You do 3 and 8 on paper. I want you to list the multiples of 3 and 8 and determine the least common multiple. You already got it, don't you, Captain? If you use a multiplication table, you can use it in this, but that's it. All right, I think we've had time. Somebody tell me the multiples of 3. Jaden.
9, 6, 9, 12, 15, 18, 21, 24, 27, 30.
Okay, can I stop there? Okay. Somebody else, give me the multiples of 8. Give me the multiples of 8, Cashton.
8, 16, 24.
8, 16, 24. Why did you stop there, Cashton?
I found another one 6, so 24.
24 there and 24 there. And so he knew his LCM equals 24. Do you have to know multiplication to be able to find your LCMs? Definitely. Okay, let's do the next one as a group. Throw that there. somebody read or just start giving me the multiples of, now we're looking for 9 and 12. So we gotta kind of think about what we're gonna have in common. Do I wanna start with the 9 or do I wanna start with the 12s? Which one would be better, do you think? I think the 12. Why do you think the 12? Who said that, Ben? Why would you start with the 12? You just feel like it's going to be easier? Okay, we'll go ahead with the 12s. So Ben, tell me the multiples of 12. 12, 24, 36. Do I need to keep going?
No.
Who said no? Jaden said no. Jaden, why not?
Because there's 36 in 12 and 36 in 9.
Because you know the 9s, 9, 18, 27, 36. And right there, Jaden said, with those multiples of 12, I know that 9 times 4 is 36, so my LCM is 36. And that is why I chose to start with the 12s. Because they're going to grow quickly. And I know my 9s by multiplication. I don't necessarily know my 12s, but I do know the 9s, so I can use some number sense to find that LCM and be able to stop. Okay? You do number 3 on your own. These are things that you're going to be doing in your homework, exactly like this. You do not have to do Venn diagrams, though, in your homework. Only you're going to do the list and another way. Yes. Yes. Good. Yep. Yes, ma'am. Check your partner. Yes. Mr. Mustache, Pencil Mustache, check with Cashton. Make sure you and Cashton and Braden all agree. Nice job, Jaslyn. Are you almost there?
Yeah,
You know the answer? What's the answer? No. Shorter. Look here. That one. What's 6 times 5? There you messed up. 30. Yeah, it should have been a 30. What is the LCM between 6 and 10? Jaslyn.
30.
Jaslyn says this LCM equals 30. Okay? Cole, give me the factors or give me the multiples of 6. 6. Keep going. 12. 18. 24. 30. Good job. Okay, I need somebody else to give me the multiples of 10. Give me the multiples of 10. Esri.
10, 20, 30.
30. And right there, I know I can stop because I know I've got 30 in both. Okay? How do you feel? Fist to 5, how do you feel about using the list method? We good? All right, 4 to 5. I figured that would be pretty solid. Now, we did prime factorization. What is the tool we use to be able to do a prime factorization? What tool would I do, Kaylee? Factor tree. So I've got to set up a factor tree for both 16 and 20. And I'm looking for my primes. Okay? And I know I would have had 2 and 10. Okay, this is prime, 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 2. Okay, do I have my factor trees?
Yeah.
Now then, this time I am going to do the prime factorization. I'm going to show you a couple of things. If I write my prime factorization for 16, 16 equals 2 times 2 times 2 times 2. Do we agree? Okay. 20 equals, I've got 2 2s, so I've got 2 times 2. I don't have this 2 though, do I? And I don't have this 2. Do you agree? But I have a 5. Now, I have my rows and I have my columns. Okay? Do I have a 5 in 16? So I can leave it like that, right? All right, now then, when we did the greatest common factor, we looked for full columns, right? Here, we bring one from every column for the LCM. I bring one from every column, and that's how I figure it out. So my LCM equals 2 times 2 times 2 times 2 times 5. Okay? So the 4 2s was 16. Do you agree? 2 times 2 times 2 times 2 was 16. What's 16 times 5? Who said that? Cashton? Cashton says 16 times 5 equals 80. So my LCM of these two numbers is 80. Okay? This is using the prime factorization. Okay? I like to do it a little bit different. I like to go and have a party. Like to go to the party. Okay, the deal with the party is, once I get a family of 2s, that's the only ones that get to go. And I want, because it's a party, I want the biggest family members of every family that comes. So if I look at my 2s, my largest grouping or family of 2s under any number is 4 of them. They're at the party. These 2 don't get to come. I already got a family of 2s. I don't need any more. I got a group of them already. But the 5 gets to come because I don't have any families with 5. And so now that family gets to come. So these are my members of people at the party, which is the same as using the prime factorization method. And I still come up with my LCM equals 80. Either way, okay, you need to be able to grab one of them and just know it, okay? Let's go to, okay, do your factor trees, 14 and 18. So this is the prime factorization method. You have to know this. Okay, you have to know it. Start out by doing your trees. So what is my LCM of 14 and 18? What is the LCM of 14 and 18? Kaylee?
126.
Kaylee says 126. 2 times 3 times 3 is 18 times 7.
Got the same answer.
Did you multiply 18 and 7? And you got 126? Okay, good job. If you're going to line them up with the rows and the columns, they have to be in order from least to greatest. Okay? If you're going to line them up with a prime factorization, they have to be in order from least to greatest. Okay? If you're going to do the party, when you found these, you know, these guys all get to go, and then you just had one more to go. Question, Ben?
I went 3, 2, 3. I did 18 and 18.
Okay, so you had 18, you said divide it by 3, and left yourself with 6, and then you got 2 and 3. But when you go to this stage, it's got to be in order from least to greatest, okay? It's okay to do it that way, as long as your prime factorization is least to greatest. Braden?
There ain't no 7 in the factor tree of 18 though.
You're right, there isn't. Oh, I put it there. I didn't mean to. Thank you. You're right, I agree with you. There is not, and I didn't mean for it to be there. And so there I should have had a space. I should have had a space, okay? Good, thank you for catching that. All right? And all of my columns, I have 2 times 3 times 3 times 7. That's my columns. Okay? 28 and 36. You do it. 28, do the factor tree for 36, and then you tell me what the LCM is. You've got this for all. Where's the largest family of 2? Just pull, how many's in? Two twos. Put a pencil. Okay. So that's 1, 2. Okay, now, got that. How many 3s? Where's the largest group of 3s? Right. So
So come
What factor is not being used?
here. You minus
There you go. And then you multiply it out. Okay. All right, here's what I've got. I've got kiddos that have gotten the prime factorization and don't know what to do with it. Give me your prime factorization of 28. 2 and 7, right? So if I was to write, I'm not going to write yet. I'm just going to leave it like this for right now. Somebody else, give me the prime factor, give me the tree, factor tree for 36. Esri,
So 3 and 12,
3 and 12.
and then 2 and 6, and then 2 and 3.
All right, these are all prime, so I can stop with that. Now, 12 is 2 times 2 times 3 times 3. Does everybody agree with that?
Well,
Or 36. Thank you. 36 is 2 times 2 times 3 times 3.
yes.
Okay, 28, according to the tree, is 2 times 2 times 7. I don't have a 3.
So
I don't have a 3, but I have a 7. Now, did you get it to there? Once you get it to there, you bring 1 down from every column to make the decision as to what to multiply. I have a column of 2's times 2 times 3 times 3 times 7. Does that help? And I multiply that all out together, and I should get 252. Okay? Question, Kaylee?
I use the party because it's way easier.
I find that the party is easier. I really do. I get my factor tree, and the minute I get the factor tree, I know what to do. I'm going to separate right here. We're going to do one more. Let's factor 24. Let's get the factors. 2 and 12, 2 and 6, 2 and 3. Do you agree? Okay? 90 is going to factor out to be 3 and 30, 3 and 10, 2 and 5. Do we agree with that? These are all primes. Does everybody agree with me?
Yes.
Now, we're talking party. Party. Where is the largest group of 2's and how many are in that group or that family? Tyler?
24 and
There's 3 2's under 24. So, I have 2 times 2 times 2. These guys got to come to the party. There's a 2 here. It doesn't get to come. Sorry, too bad. Okay, where is the largest group of 3's and how many? How many, Mr. Chance?
90 and
There's 2 3's right here, so times 3 times 3. This 3 doesn't get to come. What prime number have we not brought in? We haven't brought in the 5, so now we bring it in. 2 times 2 is 4 times 2 is, times 3 is 24 times 3 is 72 times 5 is
360.
360. Chance?
What if there's like on 2490? What if there could be like there's the same number of 2's in both of the?
What if there was 3 2's here and 3 2's here?
Yeah.
You just bring one group of them.
Oh, okay.
The other group doesn't get you because we've already got a group of 2's.
So it wouldn't matter.
It wouldn't matter. Okay? It's kind of like, think about it at your Halloween party. Do you want all witches?
No.
Well, if I got 3 witches already, I don't need any more. Okay? I might want a zombie or 2. Well, if I got 2 zombies, I don't need any more of them. See what I mean? Okay? How do you, fist of 5. prime factorization. I think if anything, that's gonna be the one that's gonna give you, and it's okay, don't look around. Some of you, we've got 3s, 4s, and 5s, okay. I wanna give you an opportunity to practice it, and that's what you got here. Your assignment has nothing in the math journal that we haven't already done, okay? So now is your time to